All right, we can't get away without doing some stoichiometry. All right, so we have our flow chart here where we've got a whole bunch of different ways that we can get to moles, okay? So we've got this sort of a relationship going on, or potentially this sort of a relationship going on, where we can use the ideal gas law to help us go from one piece to the next. But remember, the big important thing is that when we have our balanced equation, we have to go from moles to moles. Okay, so let's try one. All right, so I have some carbon dioxide, and I want to know how much carbon dioxide I can generate from this reaction of 5 grams of my hydrocarbon. All right, so in order to figure out the number of mils, I first need to figure out the number of moles. Okay, so we're going to take our 5 grams, and then here's our molar mass, 44.094 grams per mole. My balanced equation tells me I have 3 moles of carbon dioxide for every 1 mole. I'm going to get 0.340 moles. Okay, I want a volume, so that's nRT over P. So I have 0.340 moles, 0.8206 liter atmosphere mole Kelvin. I'm at STP, so I have 273.15 Kelvin. I'm at STP, so I have 1.0 atmospheres. So I have a volume of 7.63 liters. Okay. My problem asked me for milliliters, so I'll take my 7.63 liters times 1,000 milliliters in 1 liter, and I'll get 7,630 milliliters. Okay, now one nice thing though is if you're going from volume to volume and you're keeping the temperature and the pressure the same, so this is the key here, constant temperature and pressure, we can do a direct comparison using the stoichiometry because if the temperature and pressure don't change, we don't have to go through the rigmarole of calculating all of that stuff. We can actually just do this. 4.22 liters. And for my balanced equation, I have 5 oxygen for every 1. And I'm going to get 21.1 liters. And this all goes back to that molar volume. Because we know that a fixed quantity of gas has a fixed volume at STP, if we keep the temperature and pressure the same, we know that those sorts of things still ring true. So if I have fixed temperature and pressure, I can do a direct comparison there because all the ratios work out. So that's our stoichiometry.